Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of an oblique line in which we are required to connect the different dots in the given problem. That is, we have not been provided with the direct locations of the ends of the lines A and B over here. So in this case, we have been provided with partial information regarding the midpoint and the coordinate location of the different ends into the mixed mode over here. So let us see how we can connect the different dots and establish the orthographic projections of an oblique line AB. So let us first of all go through the problem statement. So point C, it is located 40 millimeter above the horizontal plane and it divides the line AB into two equal parts. The distance between the end projectors of the points B and C measured parallel to the XY reference line, it happens to be 30 millimeter. The front view of the line, it is making an angle of inclination 30 degree with respect to the horizontal plane. And point A, it is located at a distance of 50 millimeter in front of the vertical plane. And another information we have got, the shortest distance of the point B from the XY reference line happens to be 40 millimeter. So this way we have to connect different dots into the given problem and evaluate the orthographic projections of this particular line AB. And we are required to draw the front view projections, the top view projections and the left hand side view projections of the line AB, assuming that the line happens to lie in the first quadrant. Let us proceed with the construction of the orthographic projections of the line AB. So here we have got the XY reference line, X1, Y1 reference line and the transfer line at an angle of 45 degree, which we are required to convert distances from the top view into the profile plane, which will be required over here. Now here we are required to draw the front view projections, top view projections and the left hand side view projections. So the front view projections in the first quadrant, they will be drawn above the XY reference line. The top view projections in the first quadrant, they will be drawn below the XY reference line and the left hand side view projections of the line, they will be drawn on the right hand side of the front view projections of this line. Now we are provided with the basic information that point C, it is located 40 millimeter above the horizontal plane. So what we can do, we can mark this distance of 40 millimeter and corresponding to this distance of 40 millimeter above the horizontal plane, we can draw a locus line to represent the location of the point C dash in the elevation or in the front view projection over here. So the coordinate location of the point C dash has been obtained in this particular case. So we can mark the point C dash over here. Another thing, we know that this point C dash, it is going to be located in the midpoint of the line AB. That is, on this side we will be obtaining A dash C dash. On this side we will be obtaining C dash B dash. So A dash C dash will be equal to C dash B dash projection over here. Now we have been provided with another information that the distance between the end projectors of points B and C, it happens to be 30 millimeter measured along the XY reference line. So please check wherever point C dash has been located. From this point, we can draw a vertical projector line over here. That is, wherever point C dash has been located in the front view projections, on the same vertical projector line, we are going to obtain the top view corresponding to this midpoint or the point C, right? So another thing we have got that the distance between the end projectors of the points B and C, it happens to be 30 millimeter. As we have discussed earlier, here we are going to get A dash. Here we have already located C dash onto this projection line at an inclination of 30 degree, because the front view of the line, it happens to lie at an angle of 30 degree over here. So onto this projection line, point B dash will be located. So wherever B dash will be located, one vertical projector line has to be drawn. So corresponding to this vertical projector line, corresponding to the end B, we know that this distance between the endpoints of B and C, this is endpoint of B, this is endpoint of C. So this distance is provided to us as 30 millimeter. So once we have drawn this vertical projector line, so another vertical projector line we can draw at a distance of 30 millimeter from the end projector corresponding to the point C over here. So this is the end projector corresponding to the point C. We mark a distance of 30 millimeter on the right hand side, and the moment we mark this distance, we will be able to obtain the end projector corresponding to the point B into the front view as well as into the top view projections over here. And we have to extend this projector in the upward direction till this vertical projector line, it should be meeting this orientation line corresponding to the elevation of the line A dash B dash over here. So this point of intersection of this vertical projector, which is the end projector of the point B, with this inclination line or the orientation line of the front view projection of the line A dash B dash. So this intersection will provide us with the point B dash in the front view projections over here. Now we know that C dash point, it happens to be the midpoint corresponding to the line AB. So whatever is the distance of C dash B dash, so same distance will open the arc is equal to the distance C dash B dash. Keep the needle of the arc as at C dash point and mark an arc over here onto this elevation projection line, and this distance A dash C dash will be equal to the distance C dash B dash into the elevation. So this way we are able to obtain the front view projections corresponding to the line A dash B dash, for which C dash point happens to lie at the midpoint of this particular line. So we have got C dash B dash is equal to A dash C dash. So A dash point has been obtained, C dash point, it was provided to us, B dash point has been located. Since this front view projection was inclined at an angle of 30 degree with respect to the XY reference line. So having obtained the A dash, now we can obtain a vertical projector from the point A dash. Now onto this vertical projector line, point A will be lying. Similarly, onto this projector line, onto this vertical projector through the point C dash, point C in the plan will be located. Similarly, onto this vertical projector into the plan, we are going to locate the location of the point B over here. Now we have been provided with the coordinate locations corresponding to the points A and B in the top view projections over here. Point A is located 50 millimeter in front of the vertical plane. One horizontal locus line we are going to draw at a distance of 50 millimeter in front of the vertical plane. So please check, point A we have marked as 50 millimeter in front of the vertical plane. So this defines the location of the point A in the top view. So A point will be located just onto the vertical projector line which is emerging from the front view elevation projection A dash over here. Now once we are able to measure this distance of 50 millimeter, So this horizontal locus line we have drawn and extended it up to the transfer line over here. So this transfer line was drawn at an angle of 45 degree, and the purpose of this transfer line was whatever is the distance of this point A from the vertical plane in the top view projection. So this distance we are going to transfer it into the side view projections over here, right? So this way one horizontal locus line through the point A has been drawn and it has been extended to meet the transfer line at this particular juncture over here. Similarly, another information we have got corresponding to the point B top view projection. So we know that the shortest distance of the point B from the XY reference line, it happens to be 40 millimeter. So as we measure this, we can see the location of point C, it was located 40 millimeter above the horizontal plane, and since point B, it is located above the point C with respect to the horizontal plane, so this distance of the point B dash in the elevation, so this distance of the point B dash in the elevation, this is greater than 40 millimeter. So this will work out to be either 50 or 55 millimeter, whatever it works out to be. But certainly this distance of the front view elevation projection of the point B dash with respect to horizontal plane, it is greater than 40 millimeters. So this distance of plan from the vertical plane, that is, we are going to assume that the location of the point B in the plan will be marked in such a way that this point B, it will be lying at a distance of 40 millimeter in front of the vertical plane. That is, this will become the shortest distance. So this shortest distance becomes 40 millimeter in the plan. So please check, this distance happens to be 40 millimeter in the plan. So we are going to mark the shortest distance 40 millimeter. And what is this? This is the locus of point B. So once we obtain the locus of point B, so we are going to draw again a horizontal locus line, and this horizontal locus line should intersect with the vertical projector line which is emerging from the point B dash over here. So this intersection point provides us with the location of the point B in the plan. So the location of point A in the plan has been evaluated. The location of point B in the plan has been evaluated. And once we join A with B, now the intersection of this plan projection line orientation with the vertical projector line which is drawn through the point C dash, so this intersection will provide us with the location of the point C, right? So this way the front view projections corresponding to A dash, B dash and C dash points have been evaluated. The top view projections corresponding to the points A dash, B dash and C dash, they have been evaluated. Now we need to evaluate the left hand side view projections of the line, and these left hand side view projections of this line will be obtained on right hand side of the front view projections over here. So in order to obtain the left hand side view projections, whatever distances of the ends B and A, they were obtained in the top view projections, so they will be transferred using this transfer line into the profile plane projections over here. So what are those distances? So we have evaluated that end B of the line, it happens to lie 40 millimeter in front of the vertical plane. So once we take this horizontal projector line through the point B and take a vertical projector upwards, so we find this distance is equal to 40 millimeter in front of the vertical plane. Similarly, end A, it was lying at a distance of 50 millimeter in front of the vertical plane. Now we are going to draw a horizontal projection line through the point A till it intersects with the transfer line, and from this point once we draw a vertical projector upwards, so this distance of this vertical projector, this will be equal to 50 millimeter. So this distance of point A 50 millimeter in front of VP has been transferred from the top view projection into the side view projection over here. So we know that at whatever height A dash and B dash points they have been located in the front view, so corresponding to the same heights we are going to obtain the side view projections corresponding to the points A dash and B dash over here. So from B dash, let us draw a horizontal projection line. So we know that this is the height of the point B dash in the front view. At the same height, we will be obtaining the location of the point B double dash in the left hand side view projections over here. So from B dash, we have drawn a horizontal projection line and we extended up to the vertical projector line which has been obtained through the point B distance in the top view projection over here. So this is the point B projection. From point B, we have drawn this horizontal projector till it intersects with the transfer line, and from here we have drawn a vertical projector in the upward direction and extend this projector till it intersects with horizontal projector line which has been drawn through the front view point B dash over here. So B double dash point has been located. Similarly, when we draw the horizontal projector through the point A dash, so we see that at the same height the side view point will be located over here. That is A double dash point will be obtained by virtue of the horizontal projector which is emerging from the point A dash and the vertical projector which has been drawn through the transfer line corresponding to the point A in the top view projection over here. So A double dash has been obtained, B double dash point has been obtained, and similarly we can locate point C double dash also into the side view projection. So from C dash, we have drawn a horizontal projector line because the height of point C dash is also fixed. So this point C dash height has been located into the front view elevation projection. So at the same height, we are going to obtain the location of the point C double dash. And now we know the distance of the point C in the top view. It is this distance. Now from this point C, we are going to draw a horizontal projector line till it intersects with the transfer line at this point. And from this point over here, we are going to extend a vertical projector in the upward direction till this vertical projector, it intersects with the horizontal projector which is emerging from the point C dash over here. So this provides us with the location of C double dash. So this way, the left hand side view projections of this particular line, they have also been obtained into the orthographic projection. So here we can see that how we can evaluate the front view projections, the top view projections, and the left hand side view orthographic projections of an oblique line. So this is all for today. I hope that through this discussion you would have understood about how do we draw the orthographic projections of the line AB which happens to lie in the first quadrant using bits and pieces of the information which have been provided to us in the different formats and joining the dots which are provided to us through the statement of the problem over here. So we are going to continue with further discussion regarding few more illustrative cases of projections of the lines in the coming lectures. So thank you very much. Thanks a lot.